angiopoietin, sir.
Angiopoietin.
P-O-I-E-T-I. Angiopoietin.
Angiogenic.
Angiogenic. So would the kidney that's being lesioned by the diabetes produce more, right, of these proteins? Is that what it is?
They are actually, they work in the antagonist manner. So one will be increased and another will be decreased. So a normal balance should be there for a proper glomerular basement membrane functioning. So I want to see what is that chain, how the imbalance is taking place, whether which factor is increased and which one is decreased.
Coming back to the general question, so to what degree do you work with undergraduates here? Do you have interaction with the students? Do they come to your lab and do things or not?
So we,
Yeah.
She teaches.
So you teach them, okay.
Yes,
And then you bring them back to the lab. Okay, fantastic. Very good.
Yes, please, now please ask questions. Please. Anything.
What the questions better? There is no question.
We have seen patients retiring in
Yeah. Oh, so you adjusted your clinical practice based on these findings?
by and large, by the age of 10 to 15 years of standing diabetes, they do develop nephropathy, which is concurrent with the retinopathy also. But we have got a section of patients who will never go for nephropathy. Even though they have uncontrolled diabetes for longer time. So you might have to keep an eye on that. Why certain section of patients are not going for nephropathy at all. That control measures we have to take. Group of patients who have developed nephropathy, group of patients have similar duration of diabetes known. Why they are not going nephropathy, that also versus angiopoietin 1 and 2 and see what is the difference between them. Phenotypic or genetic differences are there. What exactly makes them to be resistant for nephropathy. We have seen even some patients going for nephropathy, but they have never developed hypertension. Even though stage 4 diabetic nephropathy, they will not go for hypertension. They are not on any drugs, patients anti-hypertensive drugs. At other patients, the moment they are diagnosed as diabetes, they have nephropathy already. Of course, in India we know very well, first diabetes will not be detected on an average 5 to 6 years of beginning. They don't go for regular checkup on beginning, prophylactic. So identification one, secondly classification, stratification of patient when you take for your study. And differentiating between them, what makes the patient to be resistant for nephropathy. That also you have to mention.
That is fascinating. So basically, you combine your biochemistry with the clinical research, and do you have the infrastructure to
Yeah.
you know, like do the
Yes.
clinical trials and do the genetics, and that's incredible.
We do that.
Yeah, yeah. And so you combine these to one publication, which has great try and then developing of biomarkers.
Yes,
Yeah.
so you can make one or two depending upon the parameters.
That's wonderful. Wow, good example for translational research. That's amazing.
Good afternoon, sir. I'm Professor Zubieta. I'm from the Department of Pathology. I'm a PhD scholar too. I'm also working under Professor Das, sir. And my topic for PhD is role of cilnidipine on pathophysiology of brain in hypertensive-induced TRAC, L-named hypertensive-induced TRAC. So while doing, I always think that because mainly I am focusing on a cerebral infarction. Whether after giving cilnidipine, whether the cerebral infarcted area will reduce or it will remain same. It is L-name-induced hypertensive RAS. On brain I am doing it. And I always think that, and it is I have done it and completed some work, and I have found that there is a that infarcted area has been, injuries area has been reduced. But as everybody knows that the brain structurally it is different in different parts and functionally also it is different. I always think whether it is only the cerebral part is it gives changes, so the other parts also have to extend my study. I always think about it. What do you suggest?
So this signalipine is the combination of L-type and N-type calcium channel blocker? Okay, so the one we referred, I see. And so you combine it with looking at stroke and does it cross the blood-brain barrier or it doesn't matter because you have a stroke? So where do you think the site of action happens? Is it in the central nervous system?
In the cerebral.
Do you combine it with, for example, using comparison with nifedipine, where you know it's only L-type, or? Yeah.
No, sir, I'm not comparing. I'm just seeing I'm comparing with the salt-induced and L-name-induced hypertensive rats. With control group, I have taken control group with the cilnidipine drugs, with the infusion of cilnidipine.
Very cool. Do you think that the drug acts on the blood vessels or
No, I
where?
am not doing on blood vessels.
No, but what do you hypothesize is the action?
This will after giving the cilnidipine, because cilnidipine works on both L and N type of the channels. It is a neuroprotective mechanism it has got other than a cardioprotective mechanism. So my hypothesis is it will reduce the infarcted area after giving the cilnidipine. So after inducing with the L name drug, it will give rise to infarction in the brain, and after cilnidipine it will reduce the infarcted area.
Yeah.
So I am looking for what is the change between the hypertensive induced rats and after giving the cilnidipine drug. So my question is, I am focusing only on cerebral. So because the brain has got a different area, so is it? I want to know that can I extend my studies studying the other parts of the brain also? Is it gives some?
So that's an interesting question about the research strategy, and so one of the issues with publishing is often, let's say you go now for another area, then it's not so innovative. The question. So what I'm saying is, from this observation, it would really be more interesting, I think, to dissect the mechanism. Say, hey, look, now I have an observation, it's a good model, but how does the N-type versus the L-type work? So you, instead of, let's say, going now to another area, probably it's more interesting to go deeper, and then, for example, use that there are more specific drugs. I know the conotoxin G6A is an N-type drug, and then you have, as I said, the nifedipine is an L-type drug, so you can ask the question, is it L or is it N? Because your drug doesn't let us know. Then your hypothesis is that it's probably due an antioxidant effect, so maybe you can test this with antioxidants. Can you blunt the effect or can you mimic it? And so I think one of the tricks is often to realize that a lot of the observations you make are not mechanistic enough. And the deeper you go into the mechanism, the more likely you get it into a great journal, And often the journals will criticize you if you go from one area to the other, because then they say it's incremental increase in knowledge, So unless you have a really specific question that you say, okay, what happens if the stroke happens in the hippocampus? Does it affect learning and memory? Can I basically prevent this? And then you would combine it with behaviors, like object recognition tests or something. So that's another kind of trick, is to study this at different levels, combine it with behavior and not just leave it at physiology. So when you basically try to get at the mechanism and also the functional outcome, then it's good to form teams, So let's say you recruit an undergraduate that can do all the behavior, and then combine it with what you've done.
I'm also sharing the same hypertensive marshals award.
Okay, yeah. No, it's really important, and what we do.
We are using both my students, they're using actually the same model.
Fantastic.
One way is the brain, other way is the kidney.
Yes,
And
very
studying
cool.
Differentiated.
Yes.
So it reduces the number of animal sacrifice.
Oh, that's also a very good team. Yeah, fantastic.
For that reason, we are taking that way. But purpose and objectives are same. But how
My
what-
query is,
yeah,
I know
one query is that
how to extend my
yeah,
study.
whether the, apart from the neocortex and all, whether the subcortex area need to be evaluated. That's his question.
So basically,
Yeah, subcortex area, whether they could go in depth of the, and whether it will have any impact on that.
yeah, that's a good
What is
idea.
this?
Yeah. So you would like to study the basal ganglia or something. So do you have indication that it affects
No,
that?
I do not have any.
Yeah. It would be good to basically have a rationale why you want to study deeper, you know, and what we do normally, you know, like we have every Wednesdays we have our lab meeting. So you present this to the lab meeting and then we discuss, you know, how can we push this project further. And so if you want to study, let's say, how it affects basal ganglia, then you would ask a very specific question. Does it affect, for example, decision making? And then which area of the basal ganglia could be affected, so you combine it with a mechanistic insight, you know? So it's for us always important to not only observe, because often these descriptive studies get criticized, so you would like to go from beyond the description to the mechanism, you know? So
Yes.
that's it, yeah.
Absolutely.
But I think it's a good idea to combine different projects, you know, to have
that should be
maximize the
Yes,
output.
yes.
Absolutely.
Same hypertension model, sir, and that L name, that is a NOS inhibitor, sir, nitric
Yeah.
oxide synthase inhibitor. That we are, first time we have developed hypertension model in vascular lab, sir. Then I am studying, I am taking out the kidney and seeing the expression of proteins like VEGF, ENOS and ACE, angiotensin converting enzyme. Those protein expression I am seeing, and urine I am estimating 24-hour urinary protein in rats urine and angiotensin 2 level
And total
in urine.
output.
Fantastic, yeah. So where is the NOS produced? Is it like from glia cells, or do we know?
Vascular endothelial cells.
Oh, okay, it's the endothelial cell that's produced it.
Yes.
Okay, cool.
We are storing other organs also, sir. We do not know what to do with those organs.
Yeah.
Instead of just wasting it, so
Fantastic.
we are storing other organs also.
Okay, that's really good. Yeah, and of course the question is, you know, how can this project be developed deeper into the mechanistic side, beyond pharmacology maybe, you know, I don't know. So do you do electrophysiology also in the
Yes,
lab? Do you think it would be possible?
Yes.
Yeah.
Actually,
Cherry
we have procured the radiotelemetry devices. And
Oh wow,
and
that's
now we are
amazing.
standardizing the radiotelemetry system. Once it works, then it will be actually getting many of the pictures more clear. And we are planning to have certain radiological radiographic imaging process
Oh,
in the vascular
okay.
system to see. But we don't have that in devices.
Do you have like a confocal microscopes to let's say measure
Yes,
production of
yes,
iron?
we need that once. See that one for clear.
Yeah. Because then you would be allowed to look, you know, is it, what are the vascular adipocytes affected or not? Yeah. So, I mean, I personally moving towards mice, because you can also have transgenic mice where you can activate, let's say, glia cells or something like this, or vascularization, and so I think maybe that's also future thinking, is how can we use transgenic approaches to get about these questions, and I think that would be one of the ideas of exchange. You know, when some of your people would come over,
Yes.
then we can replicate this model in, for example, a transgenic mouse, and we have a confocal microscopy to see, you know, where are these substances released and how do they act, and we have markers for inflammation and all sorts of things. So I think the visit could be very informative, and then come back and see what kind of things you need to establish the same approach here. Because ultimately it's all about going from the observational level to the mechanistic level, and the standard for mechanistic level is increasing because now we can manipulate way more specific instead of like pharmacology. So we do almost no more pharmacology much because we would release, you know, synthase or things like this and see whether that affects endogenously. Yeah, but that's cool. Thank you.
And there was a question which sir asked, what is the mechanism?
It's all about the mechanism.
You have deviated from that question. Question is, you say this is a neuroprotective drug. In what way it is neuroprotective?
What's the mechanism?
Whether it protects the brain because brain becomes resistant for ischemia, or whether it improves the blood supply and thus protect the brain. That's what exactly you wanted to know. Because we have NADP, NADM, etc. There are so many neuroprotective drugs available right now. At different stages we are using as clinicians. For example, neurocetam. Randomly we are using, we don't know how much it is useful for us. But in all acute stroke we do give which are ischemic in nature. So instead of avoiding a question, take the question outrightly and head on, so that we will develop an answer for that. That will be the better policy.
I think you have done the hard work because you established an animal model, which is very hard. And you also found a clear-cut phenomenon that is reproducible. So that's always a great thing.
I like to tell you that first 6 months they have actually lost. Because when they're using the hypertension in animal model by injecting the L-neg and salt together, the dose of the salt and or 10% whatever, dose of the salt and other things which maintain the drug and all, animals was not going to the hypertensive as that one.
Ah.
That was the things they have actually, by both the scholars, they have lost 6 months to 8 months for just standardizing. And when they standardize that actually 1 year old, now it is not taking time to do the experiment. But initially this setup itself took a lot of times.
You know, and this is so classic. I mean, basically to establish a clear-cut phenomenon that is reproducible often takes 1 year. And something that shocks me all the time is that we often establish something for 1 year, and then you get an undergraduate student, and within 2 days, 3 days, they can do exactly the same thing, what took you 1 year. But at the same time, once you have the model established, you have to ask very critical questions where you can go further and deeper and deeper, and you should never be happy with, you always have to ask, oh, this is still descriptive, so what else can I do to make it less descriptive, you know, and what new technologies are there to go further, because ultimately you really need to understand the underlying mechanism if you want to bring it to the clinic, you know, because the clinic you want to be very targeting specific, you know. It's one approach, you know, there are of course other approaches, but yeah, congratulations. I think that establishing the model in 1 year is exactly what it takes. It's nothing.
Another one is, you induced hypertension by using extra salt. Okay. There are two types of hypertension as far as salt related. Salt sensitive and salt resistant. So you should have classified the animals based on that. You have chosen the phenotypic animal which is salt sensitive, and it would have been easy for that. I don't know. Animal model I don't work, but human models I can see clinically. There are patients where just restricting their dietary salt, hypertension is controlled better. There are few people, whatever you restrict, whatever you do, they are not going to respond. And then we have estimated the electrolyte distribution in urine as well as in the blood. It will not be correlating in that particular way. So whether the same type of picture is there in rat model or you are using.
That's the knockout model they use in the Western countries. They block it, and we did not have that transgenic mice, rat, and so we went through rat for developing that whole techniques, and that we consumed some time.
Oh yeah.
Yeah, but once now it is standardized, now it is we can do it at any time.
Exactly.
And it
Now
can be
it's a
repeated
gold mine.
anywhere. Yeah, that's
And-
the pleasure they are getting it.
And sometimes it's good also to compare different species, like Norvegicus, the Norwegian red is different than the Sprague Rowley. I don't know what.
Yes.
So we often repeat it in different kinds of animals. There's also an what is it called? Hypertensive red also.
Yes.
Would be also interesting to see whether you exaggerate the effect and yeah. So yeah. Endless possibilities. You won't get bored.
Other PhD students, please ask. Nothing is silly. No question is silly questions.
Right.
Actually, my question is to Gustavo sir. So sir just told you are biomedical engineer. So I'm a biotech student. So have you did any study on prokaryotic cells? Hypoxia study on prokaryotic cells?
On what?
Prokaryotic cells.
No, I don't have any idea of that.
Okay.
Absolutely. Sorry.
What was the question? Hypoxia on?
Prokaryotic
Prokaryotic cells.
Prokaryotic cells.
Yeah, no, we have not studied prokaryotic cells.
I searched some articles also, but I didn't got any idea, so that's why I asked the question.
I have no idea. You?
No.
No, sorry. We'll come back in 10 years and respond. Can I add something before we, come to think of it? The heart, when exposed to hypoxia, as Professor Kusaldas exposes it to the brain preconditioning with hypoxia, of course, learns to handle hypoxia. This is the concept that we have in our life and our work at high altitude. And the heart, it happens the same. But actually, it happens in all tissues. It's the challenge of hypoxia stimulates a reaction to make it more resistant. That's basically the thing. And of course, it can be the production of more vascularization. It can be changes at the mitochondrial level. It can be changes in the possibly in the sodium and potassium channels that make it. In any way, in any instance, what it does, it works, it searches for the survival of the tissue under hypoxic conditions. Let me tell you that Professor Emilio Martí-Corena of Peru was a very good friend of ours, and he worked in La Oroya, Peru. It's a mining town at 3,500 meters. And he stimulated my father and me to continue our research in high altitude because he would invite us to meetings and it was stimulated. And he observed that he followed the ideas that we were talking about more resistance with my father, and he began to have patients that had coronary artery bypass. And you see, after bypass, depending on the lesion of the heart muscles, how severe the lesion was from the hypoxia they suffered. After the bypass, some of the myocardial tissue was not too functional. Of course, there was a reperfusion, of course, through the bypass, but the heart did not function so properly. So what he did is he began to take these patients on hiking to mountains up to 5,000 meters. And he also did hyperbaric chambers. He introduced them into the Peruvian Air Force chambers at sea level that were used by the Peruvian Air Force. And he would introduce them like 3 or 4 times a week during 5 hours every day and expose them to hypoxia, it turned out that he has a very interesting paper that unfortunately it's kind of not being commented much now, but I'm trying to have it seen much more, where he shows that the cardiac rehabilitation after the bypass, if you expose the whole patient, of course, to the hypoxic environment, the recovery of the cardiac muscle was much better. And he shows it with reaction and chemicals and all that. And of course, I recall that we laughed because one of the patients said, he's taking me up to the mountain, you know, to make my heart work more, but it is so cold, I'll probably get a pneumonia. But it works, it really works.
That comes under environmental biotechnology.
Can you get closer?
Your answer is related to environmental biotechnology. Environmental biotechnology.
Yeah.
No,
Biotechnology.
Oh.
It is not exactly environmental biotechnology, it is different. It is, the aspects was different.
Yeah, I see. Yeah. I didn't quite get that.
Sir, I am a PhD research scholar, registered this year only. So I am in the process of selecting a topic for the PhD thesis. So what do you think which is more rewarding in day-to-day problem-solving research or the basic science research? Which is more rewarding for a researcher who is in his early research career? How is it better to, whether it is to go to the basic science or to the day-to-day problem-solving research?
You know, my trick to find thesis projects for students is to get to know the student, because every student is different. Some people love, you know, the mechanism, the basic science. Some people are never satisfied if they characterize a neuron and say, hey, what does this neuron tell me about the patient? So basically you have to see in yourself, what is it what turns me on? Because for the rest of the life, you have to have this love to drive you, you know. So my role as a director of a lab is to find what is your personality, and your role as a postdoc student is to find what really turns you on. Because everybody is turned on by very different things, and everybody has different strength, and everybody loves different things. And in fact, that's the secret for my success, literally, because I can have a team of 10 people and everybody found exactly what they love, and then they're the best. Because I expect that everybody, once they found their project, love their project more than me and know their project better than me. So it's like conducting an orchestra. You know, the conductor is not a great cellist, but he trusts that the cellist will know better cello than the conductor. And the only role of the conductor is to combine everything together to make it work together, because the researcher often is focused on only their project. And so my role is to combine these projects, but again, together with a team, because I think also the orchestra works better if the cellist tells me, you know what, I don't think that this cello sounds good in the combination of this, I think I should be louder. So it's really an interactive process. But coming back to your question, the most important part of accredited work is to find yourself. Because if you just go into a project that doesn't excite you, you will never compete. And I tell my people, I tell them, you have to find and love your project so much that on Christmas Eve, if you're a Christian, you'd rather be in the lab